Welcome to Module 204F on diagram conversion. In Objective 2, we're going to look at how we can rearrange our wires inside our wiring diagrams in order to minimize the number of wires that go between different devices. Let's look at this schematic diagram. We have to remember that the purpose of a schematic diagram is to show us the electrical sequence between devices, but it does not show anything about the physical location. When we analyze the schematic, we can see that we've used a slightly different method of labeling our wires. Our wires are numbers within squares, and our terminals that we actually find on our devices are numbers within circles. This is another method that we can use in order to keep the terminal labeling and the wire labeling separate as well. If I were to translate this schematic diagram into a wiring diagram, I would use the exact same method I did before, where I'm going to go line by line, item by item, and make sure I'm making an interconnection to all the different devices. And as I look at the wiring diagram, I'm coming from my contactor to my first stop button in my stop-start station, then over to my maintained stop button in my second stop. This would be my emergency override. And then I come back to my start button in my stop-start station, and then I return to my controller. This is pretty normal for any stop-start station with an override device. And I can count that I have 3 wires between my stop-start station and my motor controller. And I have 2 wires between my stop-start station and my emergency shutoff switch. What if we took the exact same schematic, but we decided to rearrange the buttons in the field? Now, my maintained stop button is closer to my magnetic controller than my stop-start is. If I followed the exact same wiring pattern that I find on my schematic diagram, what I will find is that I'm going to have a lot of wires happening now. I still have 3 between my stop station and my magnetic motor controller. Now I have 4 wires between my emergency stop station and my start station. So I can see that I'm adding a lot more wiring by doing it this method. Anytime that we have this, we might have an opportunity to minimize the wiring we have between components. Let's see what would happen if I were to do one small change in my schematic diagram. If I were to simply take these 2 stop buttons, which are in series, and swap them, now I have my maintain stop button coming off my overload device instead of going to my stop-start station. The impact that has on my wiring diagram is that I will actually have fewer wires to run now. Now I'm going from my overload device to my maintain stop, to my stop station, to my start, and then back to the motor controller. Whereas before I had 3 wires between my maintain stop station and my motor controller and 4 wires between the other 2 devices. Now I have 3 and 3. The advantage I have with this, of course, is that if I have less wires, it takes less work in the field in order to install it. Also, I spend less money and I have less line drop or voltage drop on my conductors, so I know that my controls are going to work better. Drawings end up being a pretty big part of our job, so it's very important to understand not only how to read them, but how can we manipulate them to work in our advantage. Anytime I'm looking at a drawing that has multiple devices in series, for example, I can manipulate those series items in order to reduce my wire count within my conduits. Make sure you're going over this information so that you understand it, and then return to Blackboard and do the self-test. There's also worksheets on diagram conversions for you, and when you're done, continue on to 204G.